The estimated span of the planetary group is 30 trillion kilometers. During the entire season of investigation of this space, humanity has discovered 316 minor planets and 8 main ones that everybody knows about. However, "know" is too strong a word. Generally, we only understand what these planets look like and at what distance they are from the Earth. Everything else is just assumptions. To replace theory with facts, humanity regularly sends space research probes to other planets. One of the most significant and epic missions was Cassini-Huygens, whose purpose was to study Saturn and its satellites. This included answering questions like, what danger are the rings of Saturn? What does the surface of the planet actually look like? And most intriguingly, is life possible there? On October 15, 1997, Cassini was launched into space by NASA. A state-of-the-art object the size of a school bus and worth $3 billion, it required the gravitational fields of 3 planets to accelerate. It passed near Venus twice in 1998 and 1999. Then, at a speed of 69,000 km per hour, it rushed near Earth, and just a year later in 2000 it gained further momentum, passing by Jupiter. It was not easy to accelerate a device weighing 5,710 kilograms. However, with each new month it became easier, mostly because more than half of Cassini's weight was fuel, which diminished over time. After traveling 3.5 billion kilometers, Cassini approached the rings of Saturn. In photos, the rings appear smooth and ethereal. But in reality, they consist of billions of space debris pieces, ranging in size from a fingernail to a massive building. Given the speed at which Cassini was moving, even a collision with the smallest piece could instantly destroy the entire device. Fortunately, Cassini navigated the rings safely and sent unique footage to Earth, which led to some astounding discoveries. For instance, scientists once believed all of Saturn's rings were identical. Cassini's photos revealed that each ring is different, even those close to each other. Moreover, scientists discovered that thicker rings are older. Through gravitational measurements during its maneuvers, Cassini found that Saturn's rings weigh approximately 15,400 trillion tons. Most likely, Saturn's gravity is tearing apart icy moons and comets, forming the rings from their debris. In 2004, Cassini photographed something even more intriguing: small moons within the outer rings of Saturn. Scientists captured images of particles coalescing and scattering near these small satellites. In other words, Cassini documented the formation of a smaller system within a system. This stunning view provides critical insights into the processes that form planets in protoplanetary disks, potentially shedding light on the creation of our solar system. Another shocking revelation: Saturn is consuming its own rings. From the rings to Saturn's surface, there is a continuous shower of water drops and dust. Describing it as a shower is an understatement. It's more akin to a cosmic hurricane because Saturn eats as much as 45 tons of ring matter every second. Cassini documented how the dynamics of the rings, especially rings D and C, indicate they are disappearing. However, by human standards, this process is slow. Saturn won't devour its rings anytime soon. It would take at least 700,000 years. Despite the focus on the rings, Cassini's primary mission was to study Saturn and its satellites. The images captured of the planet did not disappoint. For example, Cassini recorded an incredible storm at Saturn's North Pole. This storm spans 32,000 kilometers in diameter, with winds blowing at 150 meters per second. Its shape is even more astonishing: a perfect hexagon. This hexagonal storm is nearly 3 times the size of a hurricane on Earth, and its walls plunge deep into Saturn's atmosphere, up to 100 kilometers. Research into the origins of this storm is ongoing. Saturn has 82 known satellites, each with unique characteristics. For instance, Hyperion, shaped like a 360-kilometer potato, appears to be composed entirely of rocks and ice. Its porous surface is due not to collisions but to its low density. 60% of its volume is cavities. Another satellite, Tethys, poses even more mysteries. Cassini's photos revealed bright red streaks on its surface. Their origin remains unclear. These marks look like giant cracks, as though something is splitting Tethys from within. Scientists are still unsure whether these are caused by hot magma or unique chemical compounds. But the most fascinating satellite is Titan. To explore Titan, Cassini carried the specially designed Huygens probe. On December 25, 2004, Cassini deployed Huygens into Titan's thick, hazy atmosphere. Due to immense friction, Huygens' heat shield reached temperatures of 1,500 degrees Celsius. Despite this, the probe survived and landed safely. Before Cassini's mission, nobody could imagine what Titan's surface might look like. The signs indicated that Titan had a hard surface covered with soft, light material. Further exploration revealed even more startling findings. It turns out Titan is the most Earth-like object in the solar system. Almost the entire satellite is coated with frozen hydrocarbons resembling natural gas. This makes Titan a potential goldmine for resources. If humanity mined Titan, we could supply Earth with oil for thousands of years. Most significantly, Huygens discovered that Titan's atmosphere is predominantly nitrogen, just like Earth's. Combined with the presence of complex carbon compounds, this suggests Titan could potentially support life. However, Titan's extreme cold, approximately -180 degrees Celsius, makes it uninhabitable for now. Despite the frigid conditions, Titan boasts deep lakes filled not with water, but methane and ethane. The satellite also experiences rainfall and even seasonal changes, with each season lasting 7 Earth years. If humanity ever colonizes Titan, it could serve as a cosmic station and resource hub. But Titan wasn't Cassini's only revelation. By pure chance, the mission uncovered tantalizing signs of potential life on another Saturnian moon, Enceladus. Telescopes were similarly mind-boggling. One of the most stunning and startling pictures was taken of the planet Jupiter in August 2022. Giant storms, powerful winds, and auroras can clearly be seen, and it certainly looks like Jupiter has significantly more happening than previously thought. In the photograph, you can see Jupiter's dust rings and its moons Amalthea and Adristia. Unfamiliar to many is the first picture taken of Jupiter by Andrew Ainslie Common in Ealing, London, on September 3, 1879, using a 91-centimeter reflector. This image truly highlights the imaging power of the James Webb Space Telescope, JWST. As beautiful as the images look, the colors don't match what the human eye would see, as our eyes aren't capable of detecting infrared radiation. What we are seeing is the result of image processing, mapping longer infrared wavelengths to the red end of the visible spectrum and shorter wavelengths towards the blue range. This mimics how the human eye perceives visible light. The JWST image, when compared to the latest Hubble telescope image of Jupiter, demonstrates a stark difference. The Hubble image appears more natural to the human eye, but the far greater detail captured by the JWST is undeniable. But that's not all the billion-dollar telescope has imaged and discovered. One of the primary focuses of the JWST was the exoplanet WASP-39b, located in the Virgo constellation about 700 light-years from Earth. This gas giant planet, much larger than Jupiter, orbits what astronomers call a G-type star. WASP-39b, a hot gas giant similar to Saturn, orbits very close to its star, making it an ideal target for the telescope to study its atmosphere. NASA's Hubble and Spitzer space telescopes had previously detected water vapor, potassium, and sodium in the planet's atmosphere. However, the Webb telescope's highly sensitive infrared instruments confirmed these findings, and also detected the presence of carbon dioxide. The detection of carbon dioxide is significant because it serves as a sensitive marker for heavy elements in the atmospheres of giant and rocky exoplanets. On September 5, 2022, the James Webb Space Telescope also used its near-infrared spectrograph on Mars. This instrument can easily detect the spectral signatures of carbon dioxide, water, and carbon monoxide. Additionally, a preliminary analysis of the spectrum revealed a rich array of features containing information about dust and icy clouds, even the types of rocks on Mars' surface. With such power, the JWST is just getting started. Recently, it turned its powerful gaze toward Neptune, capturing a ghostly image of the planet and 7 of its 14 known moons. Neptune, lying in the dark regions of our solar system, is about 30 times farther from the Sun than Earth. If you're wondering why Neptune's moon Triton appears to shine like a bright star in the image, it's because it is covered in a frozen sheet of condensed nitrogen that reflects about 70% of the sunlight that hits its surface. These images differ significantly from the familiar icy blue sphere we associate with Neptune. The methane gas in Neptune's atmosphere strongly absorbs red and infrared light, rendering the planet very dark at near-infrared wavelengths. The JWST also captured remarkable images of Stephan's Quintet, a group of galaxies close enough to provide astronomers with an unparalleled view of cosmic mergers and interactions. This region acts as a natural laboratory, allowing astronomers to study how galactic collisions trigger star formation. The composite image reveals clusters of millions of young stars and sweeping tails of gas and dust being pulled by gravitational interactions. The most dramatic part of the image is the immense shockwave of galaxy NGC 7318b as it crashes through the group. Another incredible sight captured by the JWST is the Tarantula Nebula. A mosaic image spans 340 light-years and showcases tens of thousands of young stars never seen before, hidden behind cosmic dust. The most active area at the center sparkles with young stars appearing blue. To the upper left of this cluster is an older star shining brightly, its characteristic 8 diffraction spikes an artifact of the telescope structure. Further from the core, cooler and denser gas takes on a reddish rust hue, indicating complex hydrocarbons that will form future stars. New images from the James Webb Space Telescope truly demonstrate its power. For example, the heart of the Phantom Galaxy has been imaged with the telescope's mid-infrared instrument. The stunning view reveals masses of gas and dust highlighted sharply within the galaxy's arms, with a dense cluster of stars at its core. Another breathtaking image is the Cosmic Cliffs, taken by JWST's near-infrared camera. The image reveals star births previously hidden from view. The Cosmic Cliffs are part of a massive gaseous cavity about 7,600 light-years away. What appears as steam rising from the cliffs is actually hot ionized gas and dust, streaming away due to intense ultraviolet radiation. Bubbles and cavities are blown into the gas and dust by the radiation and stellar winds of newborn stars. These images are amazing, but what about the telescope's ability to look back in time? In July 2022, after its first images were shared, the JWST discovered what astronomers believe to be the oldest galaxy ever observed. Named Glass Z13, this galaxy dates back to 300 million years after the Big Bang. This galaxy is so far away that its light has taken 13.4 billion years to reach us. However, due to the expansion of the universe, the actual distance between us and the galaxy is now a staggering 32 billion light-years. In the very distant future, the number of galaxies we can observe, including Glass Z13, will diminish as they slip past the observable edge of the universe. The discoveries so far have been extraordinary. Based on estimates, the JWST should have enough power to operate for about 20 years, revealing even more mysteries of the universe. This is assuming its mirrors remain intact. However, the telescope has already sustained permanent damage when a micrometeoroid struck one of its mirrors in May 2022. This caused significant but uncorrectable damage. Thankfully, the damage is small enough that it won't pose a major issue for the telescope's performance. NASA hopes such incidents will remain rare. The James Webb Space Telescope has truly changed our understanding of the cosmos, and its journey is far from over. When the tests were sent off into space, they headed toward Jupiter, Saturn, Neptune, and Uranus. Their journeys took many rare pictures. In addition to the iconic pale blue dot and the volcanic eruption on Jupiter's satellite Io, there are lesser-known but stunning images. Check out this shot of the Earth and the Moon. The image was taken as Voyager 1 headed toward Jupiter. In this image, both our planet and its satellite appear as two bows moving somewhere in the same direction. Here you can see the edge of Titan's disk, Saturn's largest satellite, captured by Voyager 2. Why does it come in two colors? It's because the mysterious haze at an altitude of several hundred miles from the atmospheric surface looks blue. The atmosphere itself appears orange, and is primarily composed of nitrogen with a mix of methane and possibly hydrogen and carbon compounds. It's believed that this is what the Earth's atmosphere was like before the emergence of life. After zooming around the planets, the Voyagers switched off their cameras and other devices to save energy. However, their remaining instruments continued to conduct research, sending data back to Earth without issue. The probes reached the edge of the solar system and then the edge of the heliosphere, a region filled with solar wind. They entered the heliopause region, where the pressure of the solar wind and interstellar plasma is balanced. In this mysterious spot, which scientists had previously studied only through simulations, the probes made astonishing discoveries. Researchers had expected the magnetic field of the galaxy near the heliopause to be tilted toward the solar magnetic field, but the probes found no such shift. Moreover, the particle density was over 40 times greater than in the solar wind. Streams of solar and interstellar particles collide here at incredible speeds, causing them to glow and form a wall of fire. Astronomers call this phenomenon the heliosphere, though it's not known for sure if it's a fire we're familiar with or something entirely different. The plasma at the outer boundary of the heliopause is around 30,000 to 50,000 Kelvin. At first it seems impossible to pass through this region unharmed, but the probes succeeded. The plasma was extremely thin, much thinner than the Earth's surface air, so it didn't heat the probes to critical temperatures. Studying the heliopause is crucial for scientists because it is the solar system's last line of defense against dangerous cosmic rays and interstellar dust. The heliosphere blocks about 70% of the lethal radiation coming from deep space. Without it, life on Earth would be impossible. As the probes ventured into interstellar space, they recorded various sounds. Though we couldn't hear them, the instruments picked up the noise and sent it to Earth. Initially, scientists couldn't determine their source. Later, they concluded that it was the sound of gas in interstellar space, and there's much more of it than previously thought. Meanwhile, the spaceships continue to transmit valuable data to Earth, even though it takes around 20 hours for their signals to reach us. Not everything runs smoothly. Voyager 1's super radio receiver failed in April 1978. Since then, it has operated on a backup receiver. Recently, something odd occurred. Voyager 1's telemetry started sending bizarre data back to Earth. Telemetry, the measurement and collection of information for the operator, indicated that the test continued to keep its antenna pointed at Earth, but the mission experts found an error. They traced the problem to a computer that had stopped working decades ago, which was corrupting the data. A command was sent to switch to the correct computer, and everything returned to normal. However, the root cause of the glitch remains unknown. Additionally, the Voyager's power sources are cooling and depleting. They can no longer fully maintain the temperature of their equipment. NASA engineers assure us that the spacecraft still has enough fuel to keep its instruments running until at least 2025. One day we will lose contact with the Voyagers, but they will continue their journey through interstellar space, mostly among emptiness. In about 30,000 years, the Voyagers will pass through the Oort cloud, a shell of comets and icy debris orbiting the solar system. In roughly 40,000 years, Voyager 1 will be closer to the star Gliese 445 17.6 light-years from Earth than to our Sun. By then, Voyager 2 will pass 1.7 light-years from the red dwarf Ross 248 in the constellation Andromeda. Looking even further into the future, in about 230 million years, the solar system and the Voyagers will complete a full orbit around the Milky Way. By then, the Earth may look entirely different. Could the probes survive this long in interstellar space? Scientists believe it depends on the density of dust in the Milky Way. Dust particles traveling at several miles per second could slowly erode the probe's shells. Even a particle the size of 1,000th of a millimeter could significantly damage the spacecraft upon impact. Simulations by Nick Oberg of the Principal Astronomical Institute in the Netherlands suggest that the Voyager golden records have the highest chance of surviving. These records carry valuable information about Earth for a potential alien encounter. Encased in a gold cover, beneath which is an aluminum layer and a copper base, these records are protected from most interstellar threats. Their half-life for plutonium-238 in the Voyager's nuclear reactor is 87.7 years, while uranium-238, used in a small part of the shielding, has a half-life of 4.5 billion years. We can barely imagine such a distant future. Scientists estimate that by then, the Milky Way will likely collide with the Andromeda Galaxy. The spiral shape of the Milky Way could be severely distorted or entirely destroyed. This collision might eject the Voyagers from the newly formed galaxy. The chance of this happening is 1 in 5. If so, the main threat to the golden records would be cosmic rays and strange hot gas atoms in intergalactic space. If the Voyagers remain within the unified galaxy, their fate will still depend on interstellar dust. However, there may not be much dust left since star formation will have mostly ceased. The Voyagers will continue to drift in a galaxy devoid of main-sequence stars. Space will be dominated by black holes and remnants of stars, white dwarfs and neutron stars. In this dark, hostile universe, the Voyagers might wander for billions of years. Yet how can the Parker Solar Probe get so close to our star without melting? To study the Sun under such extreme conditions, the probe and its instruments are equipped with a highly reflective coating and a shield that measures 2.3 meters in diameter. The shield, called the Thermal Protection System, is made of 11.5 centimeters of thick carbon composite. This allows the Parker Solar Probe to withstand external temperatures of approximately 1,370 degrees Celsius. While that may not seem like sufficient protection, the density of the Sun's corona is low, and very few particles actually strike the probe. The spacecraft and its instruments are also strategically positioned in the center of the shadow created by the shield. The Parker Solar Probe has sensors to alert it if the heat shield requires adjustment. Another layer of protection is found inside the probe. Parker has a dual array of solar panels and an advanced cooling system. The cooling system circulates water behind the solar cells, where it absorbs heat, and then pushes this heated water into radiators where it cools down. This design makes the Parker probe resistant to heat and radiation like no other spacecraft before it. Even with this level of protection due to the density of the corona, Parker can only stay in this layer of the Sun for a few hours. But how is it even possible to send a probe toward the Sun, which is 150 million kilometers away and would take an enormous amount of time to reach? Reaching the Sun isn't simple. When a spacecraft is launched into space, the speed imparted by rockets is added to Earth's orbital velocity. This means we can either increase the spacecraft's orbital energy or reduce it relative to the Sun. Most space missions use planetary gravity to accelerate spacecraft and give them more orbital energy. However, for Parker, scientists had to do the opposite and reduce its orbital energy. The Parker Solar Probe utilized multiple slingshot maneuvers using Earth, Mercury, and mostly Venus to get close to the Sun. With each flyby, the probe loses orbital energy and gets closer to the Sun, achieving perihelion distances of just 6.4 million kilometers from the Sun's surface. But did it actually touch the Sun? Unlike Earth and some other planets, the Sun doesn't have a solid surface. However, it does have a boundary where its gravitational and magnetic forces keep in solar material, called the Alfvén critical surface. Astronomers estimate this boundary to be between 10 to 20 solar radii from the Sun's surface, or about 7 to 13.8 million kilometers. With each gravitational assist, the probe reduced its distance to the Sun. When the Parker Solar Probe entered a pseudo-streamer or loop-like structure in the corona, the swirling particles began moving much slower. This indicated that magnetic fields were dominant in the region, preventing particles from escaping. This was evidence that Parker had crossed into the Alfvén critical surface. The spacecraft even recorded video of coronal streamers moving past it. This was the first time scientists could observe these structures up close. The data collected by Parker revealed that switchbacks or zigzag patterns in the solar wind are abundant near the Sun. Previously, astronomers thought these were anomalies occurring only near the Sun's poles. Parker helped confirm that these patterns originate from the solar surface and are quite common. The spacecraft also determined that the critical surface is located 18.8 solar radii from the Sun's surface. It took Parker 8 flybys and over 3 years to reach this point. However, Parker's achievements aren't limited to studying the Sun. During its flybys of Venus, the spacecraft captured groundbreaking data about the planet. Venus is mostly covered by thick clouds that obscure its surface. Parker, using its wide-field imager, managed to photograph Venus's surface in visible wavelengths from space, revealing the planet's rocky surface glowing faintly due to its extreme heat, approximately 475 degrees Celsius. So far, the Parker Solar Probe has approached the Sun to within 8.5 million kilometers, breaking the previous record of 43.5 million kilometers set by Helios 2 in 1976. Parker also shattered space speed records, traveling at 700,000 kilometers per hour during one of its approaches. At that speed, Parker could travel from Philadelphia to Washington, D.C. in 1 second or from New York to Tokyo in under a minute. This makes it the fastest human-made object ever created. As Parker continues its mission, it will make additional flybys, collecting even more data as the Sun enters its 11-year activity cycle. During this cycle, the Sun's corona will expand, giving Parker more opportunities to enter it and remain there longer. Eventually, Parker will get as close as 6.1 million kilometers from the Sun's surface, well within Mercury's orbit and closer than any spacecraft has ever ventured. While Parker's mission is ongoing, NASA plans to send the spacecraft deeper into the solar environment to further study our star. Understanding the Sun better will help scientists seek out life beyond our solar system. Eventually, as the instruments and spacecraft begin to fail, the Parker Solar Probe will melt into a scorched piece of metal orbiting the Sun. Its mission will conclude, but not before providing us with invaluable discoveries about our star. Starting around 1962, there have been interplanetary missions to study Venus, Mars, and Mercury, with missions lasting as long as 3 years. However, the tests would have to remain operational long enough to be part of the Amazing Visit project at NASA, which required 2 spacecraft to study the 4 gas giants: Jupiter, Saturn, Uranus, and Neptune. Initially, it was proposed that Explorer 1 and 2 would visit only 2 planets, reducing the overall cost of the project. Researchers examined more than 10,000 trajectories before selecting 2 that would allow them to fly by Jupiter's largest moon, Io, and then Saturn and its largest moon, Titan. This course also gave the spacecraft the opportunity to continue toward Uranus and Neptune. The idea of extraterrestrial life was on the minds of scientists. American cosmologist Carl Sagan, along with his team, created a golden record with 115 images encoded in analog format, spoken human greetings in 55 languages, a variety of Earth sounds like wind and thunder, animal noises such as birds and whales, and different music from around the world, a greeting from the children of planet Earth. What spacecraft made the first planetary mission? The original mission plan was for the spacecraft to operate and endure for only 5 years, long enough to study Jupiter, Saturn, and its rings, as well as the 2 largest moons of these planets. However, as the mission progressed, the expectations of researchers grew, and the spacecraft far exceeded what was initially expected. On May 5, 1979, Explorer 1 was 173,983 miles away as it approached Jupiter, and was able to snap pictures of its moons Io and Europa. Despite Jupiter being one of the most studied planets in our solar system, the new images provided scientists with hidden details and more information about these moons, making them appear as if they were new worlds. The new pictures of Jupiter's closest moon, Io, revealed yellow, orange, and brown surface tones, showing evidence of volcanic rock. At least 8 active volcanoes were spotted on Io, ejecting material into space, and stunning pictures of this were captured when Explorer 1 flew by. It turned out to be the most volcanically active body in the solar system. Barely a year later, on November 12, 1980, Explorer 1 approached Saturn. Expectations were greatly exceeded, and scientists were able to expand their understanding of Saturn. 3 new moons were discovered: Prometheus, Pandora, and Atlas. However, the greatest achievement was obtaining new data about Saturn's largest moon, Titan. Titan, the only moon in the solar system with a thick atmosphere, revealed that the upper layers of Saturn's atmosphere consisted of 7% helium, with the rest being hydrogen. Explorer 1 also discovered Saturn's G-rings, which were plane-shaped structures made of ice and dust. Another interesting discovery was Saturn's 6th largest moon, Enceladus, which was found to reflect more sunlight than any other object in the solar system, due to the perfect ice covering its surface. The pictures captured showed a cratered landscape, suggesting some geological activity beneath its surface, possibly a source of heat for an underground liquid ocean. Explorer 2, however, was about to make its own set of discoveries. On July 9, 1979, Explorer 2 made its closest approach to Jupiter and captured an amazing photograph of Jupiter and its moon Io, stirring up questions about the gas giant. On August 25, 1981, after successfully arriving at Saturn, the spacecraft snapped pictures of the gas giant's rings and moons. It was clear at this point that Explorer 2 could continue on its journey to Uranus, with all its instruments still operational. NASA requested additional funding and instructed the NASA Jet Propulsion Laboratory to extend the Explorer 2 mission to include Uranus and Neptune. On January 24, 1986, Explorer 2 approached Uranus from a distance of 50,600 miles above the planet's icy cloud tops. The spacecraft gathered data that revealed 2 new rings, 11 new moons, and recorded the surface temperature of Uranus at a chilling -353 degrees Fahrenheit. Uranus rotates at an odd angle, and its magnetic field is displaced from the axis and plane that all other planets are aligned with. The data also showed that both of Uranus' poles have the same temperature, even though only one receives sunlight. Scientists speculated that the planet should distribute its temperature in different ways. Recently, scientists have been going through old data and reanalyzing the 45-hour data collection of the spacecraft as it passed through Uranus, when they discovered a 60-second anomaly in its magnetic field recording. It was found that Explorer 2 flew through a plasmoid, a massive magnetic bubble that may have been carrying Uranus's atmosphere into space. All planets leak air into space, and even Earth's atmosphere does the same, but there's no need to worry. Our atmosphere has enough resources to last billions of years. When Explorer 2 approached Neptune, scientists didn't expect to see much besides darkness. NASA teams increased the size of the Deep Space Station's radio antenna in Canberra, Australia, to capture the extremely weak radio signals being transmitted from Neptune. On August 25, 1989, Explorer 2 was 30,000 miles from the 8th planet in the Solar System, approximately 30 times farther from the Sun than Earth. Neptune receives only 0.01% of the sunlight that Earth does, making it nearly completely dark. Explorer 2 began taking strange photos, which revealed the composition of the blue planet, showing the presence of methane, 6 new moons, and 4 rings. Like Saturn and Uranus, Neptune's rings and moons formed a complex interconnected system. The spacecraft also detected winds measuring 1,500 miles per hour around a strange, previously hidden feature on Neptune called the Great Dark Spot, a massive alternating storm the size of planet Earth. In fact, both Uranus and Neptune are known for having strong winds that can reach supersonic speeds, 10 to 20 times stronger than Earth's winds. Uranus and Neptune were initially considered gas giants, but during the 1990s, it was discovered that they were composed of heavier substances, leading to the creation of a new class of planets called ice giants. Triton, Neptune's moon, was no less remarkable. This moon is located to the planet's north, and is the coldest of all known celestial bodies, at a temperature of -391 degrees Fahrenheit. Explorer 2 managed to approach the planet to within 25,000 miles and found active geysers that expelled nitrogen into space. Triton was the last object that the spacecraft encountered in the Solar System before heading out into the vast unknown. Where will the explorers go next? The explorers' interplanetary missions have concluded, providing space experts with a wealth of new information and a better understanding of our solar system. These 2 spacecraft together made significant breakthroughs in cosmology and space exploration. Explorer 2 was the first to study the 4 outer planets, Jupiter, Saturn, Uranus, and Neptune, and also ventured into interstellar space in November 2018. However, when Explorer 1 entered interstellar space, the instrument measuring plasma temperature ceased functioning, while Explorer 2 still had a working instrument. Our sun does much more than provide light and warmth. The entire solar system is traveling through space and is surrounded by a bubble called the heliosphere. This bubble is constantly inflated by plasma from the Sun, known as the solar wind, which extends 11 billion miles from the Sun's outer edge, enveloping all the planets and beyond. The solar wind protects the entire solar system as it moves through space. Outside the heliosphere in interstellar space, radiation levels and cosmic rays are much higher than within the bubble. The solar wind acts as a shield, safeguarding the entire solar system as it travels through space. The heliosphere extends far beyond Pluto's orbit until it encounters the termination shock, where its movement slows due to the external pressure of the interstellar medium. Explorer 2 found that the interstellar medium is at least 54,000 degrees Fahrenheit, but the plasma is so thin and diffuse that the temperatures around Explorer 2 remained incredibly cold. The spacecraft is now on a mission to study the outer regions of the solar system and interstellar space. These two spacecraft are still speeding through interstellar space and will forever venture beyond the planetary system into the endless expanses of space ahead of them. NASA's website shows the current locations of the spacecraft as they continue their journey. On February 9, 2022, NASA's Parker Solar Probe took its first true images of Venus in the ultraviolet and near-infrared light. The spacecraft used its wide-field imager to capture the entire night side of Venus. NASA combined the images taken by the Parker Solar Probe as it passed by the planet, creating a video. The recording shows a faint glow on the planet's surface, revealing the outlines of its continents, fields, and plains. Unimaginable shining radiance of oxygen in the environment. Researchers expected the Parker test would just catch the highest points of the mists that conceal Venus, but it surpassed their assumptions and was able to see the planet's surface through the thick cloak of its atmosphere. As indicated by scientists, due to the planet's unimaginably high temperature, the rough surface of Venus sparkles like a piece of iron pulled from a produce. Well before that, the USSR longed for handling their tests on Venus, but they had a few ineffective endeavors. Venera 4 and Venera 5 were the first USSR spacecraft that managed to send important data about the planet's climate. They found that thick clouds in upwards of 3 layers surrounded it. Also, in December 1970, the Venera 7 became the first probe to land on the surface of another planet. Due to a strong cooling system, it endured 23 minutes under intense heat. With the help of measuring instruments, the probe transmitted detailed data on the temperature, pressure, and air density back to Earth. In the meantime, NASA began sending missions to Venus. It's about Enceladus, which is covered in ice, but it shines like a light. Its surface reflects more light than any other body in the solar system. When Cassini moved toward the satellite, it made fascinating shots against the backdrop of the Sun. These showed that Enceladus has its own fountains, emitting water vapor and ice into space. The temperature at the South Pole turned out to be much warmer than initially expected. Enceladus was not as cold as thought. The temperature in the south was enough to melt the ice and transform it into water. Scientists can't offer an unambiguous answer to the origin of this heat. Right now there are two assumptions. Either radioactive elements are concealed within Enceladus or warming occurs due to the strong gravity of Saturn. However, this is not the only thing. Enceladus has water, heat, and organic molecules, and these three components are essential conditions for the emergence of life. Perhaps living beings, similar to those known to humankind, are hiding only a few meters beneath the ice on Enceladus. They feed on dissolved organic compounds and replicate by some form of DNA, still new to people. Sadly, Cassini's cameras can't see through the ice. Thus, this mystery remains unsolved. Different campaigns should determine whether there's life on Enceladus. In any case, this moon is currently the most promising place for the search for extraterrestrial life in the solar system. Cassini's mission couldn't last forever. Since its launch in 1997, the probe had been operational for years. The last phase of its life was known as the grand finale. It was a self-destruct mission for science. The Cassini probe made 22 trips between Saturn and its inner rings, sending extremely valuable pictures back to Earth. Then it went directly toward the gas giant, transmitting everything in real time, and it crashed into the planet's atmosphere, fulfilling its duty to science as late as possible. Thanks to the Cassini mission, we got incredible facts about Saturn and its moons, and maybe we came close to the discovery of the first living type of life in our solar system. Another space venture, the Titan-Saturn system mission, is already being planned. The specific launch date of the mission has not yet been revealed, but it is known that it will definitely occur before 2029. After launch, the new space mission will follow the path of Cassini, and later, after 9 years, it will approach Saturn. This time, the mission won't be limited to taking photos alone. Among the plans of researchers, there's even an undertaking to send samples of Saturn's moons back to Earth. Maybe this new mission will provide answers to the questions we got thanks to Cassini. Here, among the Martian rocks and sand, lies the final resting place of one of the most significant mechanical explorers in humankind's history, the Mars Opportunity rover. The small robot was only expected to last 90 days, but it ended up exploring Mars for years. Then, one game-changing day, it went into hibernation mode, resting and waiting for a fierce global Martian dust storm to pass. However, the Mars rover never woke up again. Prepare to discover the Opportunity rover's mission, what it uncovered on the Red Planet, and how the mission ultimately came to an end for our brave little robot. On July 7, 2003 at 8:18 p.m., the Opportunity rover was launched towards Mars from Cape Canaveral, Florida. Its mission was to search for signs of ancient water that had long since vanished on the Red Planet. Opportunity was the second in a pair of identical Mars exploration rovers, with its twin, the Spirit rover, landing just weeks before on January 4, 2004. The rovers each had 6 wheels, each with its own electric motor, on what is known as a rocker-bogie system to enable and increase mobility. The rovers stood 1.5 meters tall, measured 2.3 meters wide, 1.6 meters long, and weighed around 180 kilograms each. On January 25, 2004, after traveling from Earth for 6 long months, the Opportunity rover landed on Mars in a capsule shaped like a tetrahedron, which had airbags on all sides that inflated before landing. The rover's capsule bounced at least 8 times before grinding to a halt at the center of its target location. NASA considered the landing an interplanetary hole-in-one and nicknamed the site Eagle Crater. The site was located in an area called Meridiani Planum, an extraterrestrial plane where mineral deposits could be visible. There had once been a lake inside the impact crater, making it the perfect spot for Opportunity, nicknamed OPI, to unfold itself and begin its operations. The first task on the list was to take pictures of the Martian surface that scientists back home were eager to see. The Mars rover would use its test cameras to examine the Martian horizon and take pictures of landforms that might have been formed by ancient seas or rivers. The panoramic cameras, or PanCams, were a pair of high-resolution color stereo CCD cameras. Each camera had color filters on rotating wheels, allowing specific colors to be selected for imaging. The 2 cameras were spaced about 30 centimeters apart, small enough to fit in the center of your hand, but capable of creating panoramic images as large as 4,000 pixels high and 24,000 pixels wide. The PanCams could rotate 180 degrees and spin a full 360 degrees to capture sweeping views of the Martian landscape. However, the rover initially used its navigation cameras to grab this image of Eagle Crater. Shortly after landing, the edge of the crater was about 10 meters from the rover. The size of the crater itself was estimated to be 20 meters in diameter. You can see the rover's mast, which hadn't been raised yet, and its dust-free, pristine solar panels in the photograph. In the distance you can see the bright, large rocks on the walls of the crater. Once the mast and the PanCams were raised, NASA received an astounding image from the rover showing the inside of the crater. This time, using the color filters, you can see the Martian soil areas from the now flattened airbags. On the 20th Martian day of the mission, the world would see a sunset from another world, captured by OPI's left panoramic camera. On the 24th Martian day, the rover took this picture of a mysterious outcrop, which NASA named Memorial Station in honor of the Space Shuttle Challenger astronauts. The image was a mosaic of 12 different color images using the camera's red, green, and blue filters, adjusted to approximate the colors the human eye would see. Now, there's a primary reason why the cameras are designed this way. When viewing pictures like this in false color, the differences in surface materials are more visible and easier to distinguish. The rover captured its first 360-degree image, made up of 225 frames, showing the eerie Martian landscape. Opportunity was taking many incredible and stunning photographs, but was it going to find evidence of water? It turns out it would. On March 2, 2004, Opportunity found what it was sent to discover. Researchers reported that the rock outcrop the rover explored was once covered in water. On March 18, 2004, the Opportunity rover confirmed that Mars had indeed once had a lot of liquid water. This picture shows what NASA scientists name blueberries, hematite spheres that were formed in the presence of water containing iron. Then, in late March 2004, Opportunity left its landing site and headed toward Perseverance crater. Scientists wanted to study the bedrock layers at the crater to figure out how long this part of Mars was wet. A strange picture taken by the rover on October 7, 2004, shows a peculiar knotty rock formation that scientists named WAP on the lower slopes of Perseverance crater. No one is sure how these strange rocks formed, but one theory is that the impact caused them, and another hypothesis is that water played a role. Splashing, the stone evaporated and caused their disfigured look. One of the meanderers' most intriguing finds was rocks that were like shooting stars found on Earth. A potential Opportunity had a stone-scraped spot device that it could use to bore into rocks to find their structure. Nobody was certain if this was a shooting star or not, yet on January 6, 2005, the Mars investigation robot would find the very first shooting star found on another planet. OPI's spectrometers checked the basketball-sized shooting star and found it was largely made of iron and nickel, and this isn't all the weird and fascinating things it would find. In 2010, Opportunity was eating a few pictures high up on an edge of where it had recently traveled when it thought back to snap a Martian residue demon winding through the valley underneath. One of the more dismal pictures that Opportunity snatched was this one, taken on Spring 20, 2014. OPI is looking away from the sun into Perseverance hole and sees its shadow. However, with this investigating and crossing a no-man's land, things can get dusty on the Martian fields. During the first 7 days of January 2014, Opportunity would utilize its pan cams once more and grab a self-picture of its solar chargers, showing a lot of residue covering the boards. Not bad considering it had been there for quite a long time. The boards looked nothing like when the meanderer originally landed, but the little robot forged ahead. An important day for Opportunity would come in December 2011, when it found a vein of gypsum, a mineral that forms in water. The vein wasn't very large, just as wide as your thumb and 30 centimeters long. Anyway, this was the most impressive piece of proof that liquid water once existed on Mars and that the planet might have been potentially livable, very much like Earth. Opportunity had tracked down proof of water before, but those revelations were in sandstones, and this was certainly confirmation of ancient water. To celebrate its 5,000th day on Mars in February 2018, OPI used a minute imager camera on the end of its mechanical arm to take a series of pictures that were sewn together in a self-representation. It shows the meanderer at a place called Diligence Valley on the slopes of Tri-Pit. It's not an excellent picture because the camera is a decent focus camera that was intended for close examination of rocks and Martian soil. Right now, everybody was astounded at the record-breaking robot's longevity, but the solar chargers were already covered in a lot of residue, as designers saw in previous selfies. However, in late May 2018, project researchers realized that a residue storm on Mars would have been a big one, but they had no idea how large it would be. Once every 5.5 Earth years, there is a tremendous residue storm on Mars. By June 20, 2018, NASA announced the dust storm had gone global and developed into a planetary dust event. This tempest was gigantic and made enough residue in the Martian atmosphere to totally cover the whole planet, which shut out light from the sun. Not only was the Opportunity meanderer impacted, but circling satellites with atmospheric instruments couldn't see the red planet. The greater part of Mars' features were now concealed under a far-reaching misty beige residue cloud. Opportunity would grab a few additional pictures before the dust storm hit, and take these dazzling, all-encompassing photographs of its environmental elements. These are photographs of the ruined Martian scene, Steadiness Valley, the absolute last thing the wanderer would see, and what might end up turning into a robot burial ground. Only 10 days before this beast storm, Opportunity had sent data demonstrating the tempest was lifting enormous amounts of residue all around a temp cavity, where it was examining and transforming day into night. Oppie would get another picture just before it powered off and snapped this photograph showing Mars totally dim. The Wanderer's batteries were falling short on power at this point, and minutes after getting this data, the solar-powered robot geologist shut down, went into hibernation mode to brave the tempest, and hopefully recharged its batteries to reawaken after it was over. But that never happened. The Martian residue that forms beautiful examples in the world's surface would turn out to be deadly for the automated meanderer. The tempest started to fade away in late July, and by mid-September, it died down enough for NASA designers to attempt to contact Opportunity. They spent the next 8 months and sent more than 1,000 orders to attempt to awaken the robot. But on February 13, 2019, with some bitterness and tears, NASA reported that the Opportunity meanderer was dead. A day after the last calls to awaken it went unanswered. Sort of a sad story for our mechanical Voyager, but what a triumph the mission was. Opportunity was the longest-lived wanderer ever shipped off another planet, and explored the red fields of Mars for over 15 years, snapping photographs and uncovering signs and proof of the planet's watery, far-off past. The meanderer had voyaged in excess of 32 kilometers, its progress seen best on this map with the U.S. Washington, D.C. state displayed for scale. Furthermore, by the way, you may be wondering what happened to Opportunity's twin, the Spirit Mars Wanderer. It quit communicating with NASA on spring 22, 2010. The robot stalled out in a sand trap, and its batteries eventually died. Anyway, it also made it past its original mission guarantee of 90 Martian days and endured 2,200 spirits, or 2,266 Earth days. The two meanderers opened a treasure trove of revelation on Mars, demonstrating that the planet once had water and laying the foundation for future missions to Mars, including selecting landing sites. Together they returned 342,432 crude pictures and voyaged almost 53 kilometers, showing us what being on another planet looks like. There's nothing left but to thank these little robots for their service. Maybe future monitored missions to Mars could recover these two mechanical legends. Without the sun, no life on Earth would be conceivable, but this monstrous chunk of blistering plasma can also compromise us. Its eruptions of radiation, otherwise known as solar flares, and its explosive discharges of plasma, called coronal mass ejections, combined with extraordinary magnetic fields, can be alarming. Despite the sun's movement causing terrific auroras on Earth, shuttle satellites, high-flying planes, and even astronauts can be in peril because of solar storms. Our telecommunications, navigation systems, and power grids can fail to properly work. We haven't been able to comprehend the sun and how it functions or when it's tossing a gigantic ball of blazing plasma our way. For this reason, researchers have long longed for studying our star from a close distance. We know that the solar wind is a constant stream of charged particles that gain enough speed to escape the sun's peripheral layer, the corona, but we don't know how energy and intensity travel through the corona or what accelerates solar energetic particles. Astronomers have been looking for the answers to these questions for a long time, but with no result. Finding answers meant sending a rocket through the corona, which reaches around 1.1 million degrees Celsius, and it seemed impossible to achieve until recently. This is what the Parker Solar Probe was made for, and it's truly a wonder of human innovation. The first American shuttle to fly by and study Venus in 1962 was the Sailor 2 space probe. The data it collected turned all ideas about the world's twin upside down. The probe showed a ruined, intensely hot world with temperatures reaching 900 degrees Fahrenheit. The thick air of Venus was found to consist of corrosive sulfuric acid and carbon dioxide, and the atmospheric pressure was multiple times more significant than Earth's, enough to crush any spacecraft. The first close-up picture of the planet was sent by the Sailor 10 probe in 1974. The picture was altered to show what Venus would look like in color, as seen by the human eye. It shows thick clouds of carbon dioxide surrounding the intensely hot planet. Furthermore, the Venera 9 and Venera 10 probes took their first pictures directly from the planet's surface. Arriving a couple of days apart in October 1975, to keep the cameras from leaving service immediately, they were placed inside the spacecraft in a protected compartment through a special window. Light from the surface reached the periscopic device, which then guided it to the camera. The pictures lacked detail and appeared in black and white because the color cameras couldn't endure the high temperatures and pressures of the planet, but for the first time, people could see the surface of a world found 61 million kilometers from Earth at its closest. These were the last pictures of Venus taken by the Soviet probes, but the photo shoots of the planet were just beginning. In 1989, the US launched the Magellan spacecraft, which brought us many clear pictures of Venus. They show the ancient volcanoes of the planet, remarkable impact craters, and unbelievably massive mountains. The tallest of them, Maxwell Montes, is 11 kilometers high, while Mount Everest is only 8.8 kilometers high. The dark crater to the left or more toward the middle is called Cleopatra, and the dark stripes in the picture are unmapped spots among the areas of Venus shown by Magellan. There's something stunning located in the Estella region of Venus. This is a volcanic feature 66 kilometers across the base. There are also several endless lines across the area. These are tesserae, structurally complex units that cover around 8% of the surface of Venus, usually occurring as elevated crustal levels that are affected by magma flows from the nearby volcanic plains. So far, such features have only been found on the surface of Venus. Moreover, here's another unique area of the planet with a diameter of about 300 kilometers, a massive round structure near the center of the picture. It's the Giant Point Crown, a volcanic feature around 200 kilometers in width. Crowns are remarkable, ring-shaped structures on Venus. They were formed by tufts of superhot stone moving from deep inside the planet through the mantle and crust. Not far from the crown there's something else, a supposed hotcake vault, roughly 35 kilometers in width. Surprising in appearance, these hotcake vaults are generally 2 or 3 kilometers in diameter, about 1 kilometer high, and are astonishingly round in shape. Researchers say they were formed by ancient eruptions of a very thick magma. The planet previously appeared to be devoid of any interior energy, but it turned out to be very dynamic. Structural movement might still continue in the depths of Venus, and volcanoes might still erupt magma on its surface. This is the volcano Mat Mons. Although it's not a real direct picture, the Magdalene spacecraft couldn't see the surface of Venus through the thick layer of clouds, but its onboard radar surveyed the planet and transmitted the results to Earth. Here, a computer-generated image of Venus is shown, based on the collected data. Mat Mons is the tallest volcano on Venus, standing 8 kilometers high, and researchers suspect a recent eruption. You can see a massive pit in its center and a chain of tiny cavities spread around the area. The pictures are fantastic, but what about this discussion of possible life living in the clouds of Venus? Astronomers have long speculated that Venus clouds may be home to organisms. Not unlike the extraordinarily high heat on the planet's surface, the temperature in the Venusian high clouds reaches a comfortable 30 degrees Celsius. Although these clouds also contain around 90% sulfuric acid, researchers at the Massachusetts Institute of Technology are currently searching for superorganisms in the planet's clouds. NASA is also planning to launch 2 additional missions, the Da Vinci and Veritas missions, to try to uncover more about Venus. The European Space Agency will send the Imagine orbiter to the planet, and Russia is preparing a project called Venera D. Roscosmos plans to send an orbiter and a lander to Venus, and it's hoped that the lander will be able to endure the harsh conditions for a whole month. The orbiter and lander are expected to send many pictures of Venus to Earth in visible and near-infrared light. To allow us to see deep space, the makers of the Hubble Space Telescope had to really buckle down. The need for an orbital observatory was discussed back in the 1970s. Researchers wanted to get clearer pictures of deep space than those taken from Earth, as our atmosphere distorts and absorbs light. We will show you some additional fantastic pictures, but first, a little quick history of Hubble. In 1977, the U.S. Congress authorized the construction of a space telescope with the help of NASA. They chose to name it after the great astronomer Edwin Hubble. The most difficult task was to make the huge observatory mirror. It was made of heat-resistant glass with exceptionally thin yet tough coatings. a layer of aluminum, 65 nanometers thick, protected with a magnesium fluoride layer, 25 nanometers thick. The entire space telescope ended up being almost the size of a school bus. Its primary mirror weighed 827 kilograms and had a diameter of 2.4 meters. This mirror captures light from a space object and reflects it onto a secondary mirror, 0.3 meters in diameter. The smaller mirror was placed in the optical tube, reflecting light through an opening in the primary mirror, forming a picture in the telescope. From there it was sent to scientific instruments. At the time of Hubble's launch there were 6 such instruments. These were wide-field and planetary cameras, equipped with a set of 48 light filters to highlight light spectra. The wide-field camera had a large field of view, and the planetary one made it possible to significantly increase the observation points. Another device, a high-resolution spectrograph, was designed to work in the ultraviolet range. With its help, the telescope could scan faint objects captured by a special camera. The fast photometer could observe variable stars and other objects with fluctuating brightness, and the fine guidance sensors recorded changes in the position of the object. Scientific instruments were located in the tail section of the Hubble Space Telescope, closer to the center. There were 6 gyroscopes designed for the telescope's movements while pointing at an object. Furthermore, 4 reaction wheels allowed the telescope to adjust its overall direction and capture an object. 2 main computers were placed in the central compartment. One was responsible for providing commands to the onboard devices and sending data to Earth, while the other controlled the gyroscopes and other system functions. The telescope was also equipped with 2 wing-like solar panels, each measuring 12.1 by 2.5 meters. These converted solar energy into power, and part of this power powered the operation of the telescope. The rest was stored in onboard batteries for when Hubble was in Earth's shadow. However, the telescope consumes an average of just 2,100 watts of power each day, which is about equivalent to 5 refrigerators. In doing so, it orbits the Earth at a cruising speed of about 27,350 kilometers per hour, completing one orbit every 95 minutes. To maintain constant contact with Earth, 4 receiving antennas were placed in the space of its wings. All data and commands are transmitted via satellites. Astronomers were eager for Hubble to be ready for launch. Finally, in 1990, the Space Shuttle Discovery launched with the telescope, which weighed around 10,800 kilograms, about the weight of 2 fully grown African elephants. The shuttle safely carried the heavy payload to a low orbit, about 550 kilometers above Earth. Shortly after, researchers received the much-anticipated pictures, and instead of praise they got back a series of blurry images. Hubble's large mirror clearly had an optical flaw. There was a deviation, 1/50th the thickness of a human hair, but that was enough to affect the clarity of Hubble's early pictures. Spacewalking astronauts fixed, maintained, and upgraded the telescope during 4 servicing missions. Hubble has been observing the universe for more than 30 years, continually surprising us because the telescope is around 10 billion times as sensitive as the human eye. Even though Hubble captures everything in black and white, researchers later modified these images using a process that simulates the normal perception of color by human eyes. Let's investigate the most stunning of the million or more images captured by the telescope. This is the Butterfly Nebula, located between 2,500 to 3,800 light-years away. NGC 6302 got its name from the dying central star inside the nebula. The star is especially hot and shines brightly in ultraviolet light. The gas wings of the butterfly are around 20,000 degrees Celsius, rushing through space at more than 965,000 kilometers per hour. Another Hubble image shows a blue light stream of electrons and other subatomic particles at the center of the M87 galaxy. Particles pulled in by a massive black hole are accelerated to speeds close to the speed of light. A huge black hole at the center of M87 consumes about 2 billion times the mass of our Sun. The image of the pillars of creation in the Eagle Nebula is considered an emblem of our universe's glory. These radiant pillars of gas and dust look as if they were created by some higher power. Their strange shapes are illuminated by intense ultraviolet radiation from young massive stars that have gathered around the pillars. Meanwhile, the areas within the pillars hidden from our view are already forming new stars. These four fantastic space objects were discovered by Hubble nearly simultaneously. The telescope captured a very youthful galaxy, UGC 10214, 400 light-years from Earth. Around 100 to 200 million years ago, the galaxy collided with a smaller neighboring galaxy, and took from it a long tail of stars and gas. The fledgling galaxy floats across space with 6,000 other galaxies in the background. Another picture shows a breathtaking collision between two spiral galaxies, named the Mice. Eventually they will merge, and the same fate awaits the Milky Way and the Andromeda Galaxy, which are moving closer to each other. Hubble imaged the astounding cone cloud. It seems to be a rough mountaintop like a giant space pile. Obviously, rather than solid rock, it consists of cold gas and dust. Hubble has even looked into a divine maternity ward called the Swan Cloud, or M17. The light comes from a cluster of stars where the seeds of planetary systems are hidden. The brilliant lights in this picture look like the lights of a night city. This is what the universe cluster Able 370, found 4 billion light-years away, looks like. Ensnared among many galaxies in this interstellar nursery are mysterious arcs of blue light. These were created by light distorted by the gravity of galaxies situated behind the bright ones. They're too faint for Hubble to capture directly, but the cluster's gravity behaves like a colossal lens, amplifying and stretching the images of distant galaxies. Something similar can be seen in a place of mirrors due to the effect of gravitational lensing in the cluster. Various copies of nearly 100 distant galaxies have appeared. The most shocking example is the mythical serpent. There are several copied images of this twisting galaxy, stretched along an arc. The following picture is unique in that it generally confirms the presence of mysterious dark matter. For astronomers, this image is precious. The cluster of galaxies CI 0024 plus 17, which lies 5 billion light-years from us, is surrounded by a strange ring-like structure. Researchers believe that long ago, there was an impact between two enormous clusters. During such an event, clusters of large size can't remain intact due to the gravity of their own stars. This could be dark matter, which eventually gathered together and formed a ring. Generally, dark matter composed of elementary particles still unclear to science is invisible. However, distant galaxies in the CI 0024 plus 17 cluster illuminated its cloud with their radiation. Finally, you'll see what the universe truly looks like. In 1995, astronomers decided not to focus on a galaxy or a star as they usually do. This time they picked a piece of dark sky over the constellation as a significant target. Make a circle the size of a dime with your fingers and look through it. This is the field of view Hubble had then, and this was enough for the telescope to make a revolution in cosmology. Hubble was able to identify over 1,500 galaxies at different stages in their development, some of which were probably formed during the early stages of our universe's formation. This is how the Hubble Deep Field was made. But it didn't end there. In that same year, the first version of the Hubble Ultra Deep Field image was created, containing an estimated 10,000 galaxies. The description contains galaxies of different ages, including the most distant red faint galaxies. Researchers believe these were born during the earliest stages of our universe, when it was only around 800 million years old. Then, in 2012, astronomers unveiled the Hubble Extreme Deep Field. It was assembled by combining 10 years of the telescope's data, over 2,000 images. The resulting images contained even dimmer and more distant galaxies than before, taken by the near-infrared camera and the advanced camera for surveys. Later, even more galaxies were added to the image. Can Hubble further improve its image of the universe? No one knows for sure. The telescope is aging. In the summer of 2021, it went offline for a month due to a failure of its main computer, and after a couple of months there were issues with the synchronization of internal messages. However, the problems were fixed from Earth. The observatory has also been repaired and upgraded 5 times in space. But despite being in low orbit, no further missions are planned, so there will be no one to fix the telescope in case of a glitch. Even without significant issues, it can still fall back to Earth. During past Hubble maintenance missions, researchers equipped the telescope with additional tools, such as ACS and NICMOS cameras. So, with age, this piece of equipment gained around 1,350 kilograms in weight. The extra weight and the condition of free flight gradually shortened the observatory's orbit and brought it closer to Earth. To prevent disaster, space explorers prepared a device to decommission the telescope if necessary. It will be allowed to deorbit and fall into the Pacific Ocean or be sent deep into space. In any case, for now, no one is in a hurry to say goodbye to the Great Telescope. Engineering studies give Hubble a chance to continue working until 2030 to 2040, even without fixes. If this happens, Hubble will have time to work in tandem with the cutting-edge James Webb Space Telescope. Webb can observe the universe in infrared light, while Hubble is stronger in the optical and ultraviolet range. The two telescopes would be able to study the same objects or phenomena from different perspectives. But regardless of how the situation unfolds, Hubble's iconic images will never be forgotten. The telescope has allowed us to see galaxies at all stages of their evolution, and has discovered protoplanetary disks, distant stars, exoplanets, and black holes. It showed that space is not empty and dark, but bright and filled with celestial bodies. Hubble even did the impossible. It sent us to the universe as it was 13.4 billion years ago. Did you know that right now, while you're watching this video, the telescope's huge eye is observing the depths of space from Earth's orbit? You can indeed even jump into the Space Telescope live right now. You'll find the link in the description section. We hope you enjoyed the video. Let us know what you think about it in the comments, and make sure to stay tuned here for even more amazing discoveries from our universe. Thanks for watching.